Hello, welcome to the second video in our series on programming with Python and R, and in this video we'll be learning about indexing and slicing. So if you watched the last video, in that one we imported data from a spreadsheet that was formatted as a CSV or comma separated value file. So in Python the way we imported this is we read through it for the text columns of the spreadsheet. We imported them as something called lists, so that's a one-dimensional set of data where we had one list for each column. And then we used NumPy arrays for the columns that were numeric. In R, we imported the whole thing at once into something called a data frame, and each column within the data frame was something called a vector that could contain either numeric or text values. And in both cases we got to the point where we could extract values from the 15th observation for several of these variables. So if you followed along with that, we'll be picking up right where we left off. If you're just jumping in now, there's a link in the description to a GitHub site where you can get the data set as well as the code from last time. Okay, so here are the specific learning objectives of this video, in case you don't really know what I mean by indexing and slicing. So from those one-dimensional collections of values, your list or array or vector, depending on what we're talking about. So what I just showed you was an example where we got the 15th value. So for example, how could I get the third value or something like that? If I just want the last value, how would I get that one? Say I want a subset, like I want to get items 5 through 20. How would I do that? Or a different subset where I just wanted to get items 2, 3, and 7. What if I wanted everything except for 2, 3, and 7? How would I extract that? And then some things that start to get really useful for data analysis. How can I subset one of these lists or vectors or arrays based on the values within it? Like if I only want ones that are above a certain value or below a certain value or something like that. And how can I extract items from one list or one array or one vector based on the values in a different one? And so you'll have an exercise at the end where you will find the first 5 stem heights above 2 meters. So that's the sort of thing you're going to be able to do when you're done with this video. So a quick reminder, I'm showing you 2 different languages so you can get more of a broad feel for computer science and programming and how it works. But you're going to be least confused if you pick just one of these that you are actively following along with. So either pick Python or R, whichever is the higher priority for you in your work, and actively code and follow along with that. Do that exercise in that language. And for the other half of the video, you can sit back and kind of just watch it and get a feel for how this work would be different in that other language. So you can always watch these again if you change your mind about which language you want to learn. And so I encourage you to pause and go back as often as you need in these. There's also a table of contents in the description, so you can quickly jump to sections that are of interest to you. And with that, let's get started with Python. Okay, so let's go back into Thonny, and this is our script that we have from last time. So I'm going to start a new script for our work today. And let's save it. So it's very important right now that you save it in the same folder where you have the script from last time called dataimport.py, as well as the dataset. So if I look at all files, I'll also see my CSV dataset that I had in here. So those should all be in the same folder. So I'll call this one indexing.py. Now I want to import the data again so that I can start working with it for some indexing examples. And so I could copy and paste all of this code for import. But as a general rule of thumb, anytime you find yourself copying and pasting more than 1 or 2 lines of code, you should stop and ask yourself if there's a better way to do it. Because as you know, if you're a scientist, like you send something to your advisor or out for peer review and they say, oh, can you change this thing? And so you have to go back and revise it and redo the analysis. If you're changing something where you've copied it a dozen different places in your code, now you got to go hunt down those dozen different places and change them all in the same way. So the best way to do it is to just have one place that you have to make those changes. So that's why I say avoid copying and pasting. And I'll show you other ways to avoid copying and pasting in later videos. So I don't want to copy and paste all of this. What I'm going to do instead is say, and put it right on the very first line here, from data import. So this should match the file name of your data import file, just leave off the .py at the end. Import. And import is a special keyword. It's totally unrelated to the fact that I called this one data import. I'm just saying, what variables do I want to import from this script? And so let's see, what did I have? Longitude, latitude, elevation. I had stem height, stem diameter, stem density. In fact, I'll make a line break here. And let's see, I had accession and species, right? And so I also had some stuff afterwards where I was just kind of exploring and making sure that it imported right and seeing how I could transform the variables. Right now I don't need to do any of that again, so I'm going to comment it all out. And that means that I can easily uncomment if I want to go rerun these lines again later. But for now they're not part of what I need, so I'm going to comment them out so it doesn't execute them. So then, if I run this script as it is right now, I might need parentheses. Let's try that. Trailing comma not allowed without parentheses. Well, I have a comma here. Oh, I think it's probably this parentheses at the end of the line, actually. What I might be able to do is, this tells it that I'm making a line break, but I'm not actually done with the command. So let's see about that. Yeah, that will work. So yeah, FYI, I put this backslash here. Note it's a backslash, not a forward slash. And so that said, I'm not done with my command yet, but I'm inserting a line break just for the sake of space. And so after I run that, I see now I have these 8 variables that I specified here. Right, and I could double check that. I want to print the first accession name to see that it actually worked. There's my first accession name. Right, and so I gave an example before of how would I extract item number 3. So, and I kind of already did that, where I used 0 to index the first item. So if I want the third one, I'm going to put a 2 in there. So remember, with Python, we start numbering from 0. Oh, and I have to use a print command. See, I'm doing it too. I'm getting this mixed up with R where I would not need the print command. Right, and so that prints out the third accession name. What if I want the last one? In Python, we can actually put in a -1, and that tells it that we want the last one in the list. Now, if you're more interested in R, know that negative indices mean something different in R. We're going to go over that. So it's a little bit of a different syntax. So I've run that. Now I see the first one and the last one. And I can confirm that these are the third and last accessions by double checking on the spreadsheet. So I see, okay, number 3, which is a row 4 because it counts the header row here, but we were starting counting from here. Yes, that's the third item. If I scroll to the bottom, I see that 220 was the last one that was listed. Now what if I just wanted to get a subset? Previously I demonstrated how to get the first 20, and I said I would explain it later, so now is later and I'm going to explain it. So this is something called slicing in Python. We don't really call it slicing in R. Well, some people do if they, if they started from another language first. So right, if I run that, that got me the first 20. So let me explain what this colon means. So before the colon, tells you where you want to start. So say I only wanted to start at number 50, or we can put in 49. Right, I could put that in there like that. Save it and run it. Actually, maybe I'll comment these out just to make it so I know exactly what input I'm looking at. Right, and I see, it's starting a good part of the way through. If I really wanted to double check again, I could say, okay, is that number 50? Yeah. And then it's going all the way to the end. And so, as you might have guessed from my command before, the number that you put after the column is where you want to end. So here I left the first part blank and then just put a number after, but you can also put numbers before and after. Actually, I'll again comment it out, so I'm just running one at a time and I can tell exactly what I'm looking at. Right, so then that started where I told it and just printed those out. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 60 minus 49 is 11, right? But if I look for number 60, right, number 60 is actually this Russia 73 versus when I did 49 to 60, it gave me 72. So when you index or when you slice like this, it actually stops one position before this position that you give it in the end, which sounds maybe a little counterintuitive, but the reason why they do it that way, I think, is if, say, I do it like this. So this is going to be the first one and then stop it at number 5. I get exactly 5. So you're kind of, if you don't put anything in this first part, then you're telling it how many you want, right? Because this is position 0, 1, 2, 3, 4, and then position 5 is the one that comes after and it stops before that. So it's just a little thing where you have to remember how it works. Okay, I have a quick exercise just to make you sure you've understood that so far. So say I wanted to do something a little bit programmatically, like I was writing a script and I want to be able to adjust what my start position is for slicing and how many items I return. So I've set these variables, say, at the top of my script, and I would be able to change them later to change my analysis. Right, so fill in here using these variable names rather than the numbers to get that start position and that number of items to return. So pause the video and try that out. Okay, welcome back. So for the start position, that's what I'm going to put before the colon, right? And then after the colon, I'm going to use parentheses. They might not really be necessary, but they just make it a little bit more readable to me. I'm going to add these together. And let me print it out so that I can see the results. And I'll comment this one out. All right, I'll save that and I will run it. And I did indeed get 5 of them. Let's see, it starts at number 11. If I want to make sure that's really position 10, I can double check that. Position 10, which of course is the 11th item, so that probably is correct. Ooh. Yes. Right, so starting at Russia number 11, and then it returns 5 of them. Right, or if you really wanted to be able to think of it as this is the 10th item, you could change it like this. So, oh, that works on some other text editors, but not this one. I tried highlighting it and then pressing parentheses. So, right. I could subtract 1 from it so that I pretend like I'm starting the index at 1 if I really wanted to do that. And then it would start at number 10. So depending on how you want to think about these indices. If you're going to use Python a lot, you probably should get used to thinking about indexing from 0. But anyway, if I do that, now I have the ability to, say, change this. And I just have to change this part up here where I've sort of given myself something that makes sense to me to look at, and I don't have to change this part down here, which maybe is a little bit harder to read. Now there's one more colon that you can actually add. Let me put in some other annotation here. Okay, getting back to what I was saying. So what's going to happen when I do this? So if I run it like this with this 2 in here, what it's actually doing is giving me every other one. And I can double check that by looking in the spreadsheet. Yeah, it's 1, 3, 5, 7, etc. Right, so that tells it that you want to be skipping some. Now, in routine data analysis, there isn't a whole lot of reason for this, but maybe if you're trying to analyze a small subset of your data before you look at the whole thing, maybe because there's a lot of processing time or something, this might come in handy. It's also handy for if you want to take a list and make it go backwards. Right? I can actually put a -1 in there, and then it starts all the way from the end and then goes to the beginning. So you can use both positive and negative numbers in there. I can combine that with putting numbers in these other positions. So if I do this, what do you think it'll get? Right, that, oh, I did it wrong. I think I have to, because I'm going backwards, I have to start at number 20. Right, yeah, so that goes to from the end to number 20. Actually, I didn't do it wrong because I didn't tell you what the answer was going to be. But if I start at 20 and then run it, that's going to get me the first 20 but printed backwards. And I should note that I have been just printing all of these out and then not doing anything with them. But I can always assign these to new variable names so that I can then do something else with them. Right, so I make a new list that's just this subset of the accession list. And then I can take the first 5 items of that list, for example. Okay, so that's indexing and slicing. If you want to know more about it, well, just experiment to see if it works the way you think it does, especially because there's this kind of confusing thing with it stopping right before a number. In fact, when I did that 20 backwards, it actually gave me 21 because I told it to start at position 20, which is actually the 21st element. So personally, I always like to do a small example, check that it works the way I think it does, and then go from there onto the actual analysis. And of course, as I was going to say, you can always Google it. There are lots of lessons on how to do this because this is, very, very important to Python. Okay, so that's if I want to get a bunch of things in a series, but what if I just want a list that is like particular elements, but they're not some like evenly spaced series of numbers? Like say I wanted like positions 2, 5, and 21. Right, and so I'm actually constructing a list here by using these square brackets. So maybe I'll put that into a variable itself. Indices I want. Right, and so I'm going to give you sort of a recipe for doing this. You don't have to understand every piece of this recipe right now because it involves something called a list comprehension that I'm going to cover in more detail in another video. But because this is a common task you might do when subsetting your data, I'm going to show you how to do it now. So to make a list comprehension, I also use square brackets. So I can say accession I for I in indices I want. So that's going, so this for I in indices I want is basically going to one at a time go through these items 2, 5, and 21. And then this is showing what's getting returned, which in this case is the accession at that particular position. And in this case, I'll print it out to view it because I don't plan to do anything else with it. Right, and so that gives me those particular positions. So that would be row 3, row 6, row 22. I can look at that and confirm. So 3, 6, 22. Yeah, and those are the same numbers. So that's how I would do that. Say I wanted everything that wasn't that. Now this will get a little bit more complicated, and we're going to do something called a range, which basically will create like a set of numbers 0 all the way up to the number that you want, to avoid you having to type all of those numbers out in a list. I can also say Okay, how many observations do I have? Because I'm going to need that here. So if I do range for that, that's going to be 0 all the way up to the number right before that. In other words, you can think of it as going to give me the full number of indices I would need to index this. So I can say accession I again for I in range and obs. And this all by itself would just give you the accession list back. But I can add something to that. I can say if I is not in indices I want. So this is one of the nice things about Python, is that you can write these commands that almost sound like a sentence in English. Right, so I'm saying I'm going to go through all of these numbers, 0 up to the one right before the number of observations. And I'm going to check whether or not that number is in this list that I made. And if the number is not in the list, then I'm going to return the accession at that position. So if I print that out, I find that I misspelled something. And I know that right away because it says this name is not defined. That just means I'm using a variable name that doesn't exist yet. 99% of the time that means I misspelled it. I can see, oh yeah, I misspelled it right there. Okay. So I still left my first print command up where I got those 3, 6, and 27, and I look down here, 3 is missing, 6 is missing, 27 is missing. So that worked as well. So let's just do a quick exercise here, and I won't put the solution up to save time, but see what happens when you change the indices I want list to contain different numbers, or put the numbers in a different order and see what happens. And then maybe also try subsetting some of the other lists, like say stem density, in the same way. So say I want to subset by value. For example, I have the stem density variable. So I can print that out and take a look at it. And say that I think it's really weird for values to be below 20. And so I only want to examine values that are above 20. Say if I'm taking an average or something like that. I can do I'll make it a very long variable name, but it explains what I'm getting. So here I don't have to make indices or a range. I can actually do a list comprehension right on the list elements. And again, I can make an if clause. All right, so SD is going to one by one go through these items in my stem density list. And I can say, okay, I want it if SD is greater than or equal to, that's what this greater than followed by an equal sign means, 20. And then I can print that out to see what it looks like when it's all made. In fact, that's such a long variable name, I'm going to copy and paste it. Okay, and now I only get the values that were 20 or higher. Okay, so what if I wanted something different? I wanted to get all the stem density values, but only for Miscanthus sinensis. So we had two species in this experiment, Sinensis and Sacroflorus, and they're indicated by the species column. So how would we do that subsetting? So as you may guess, that's also list comprehension. So because we're using two different lists / arrays here, we are going to go back to doing indexing rather than going straight through the list. So, right, we'll do I in range number of observations again. Of course, we're going to need a for before that. So we're always going to have this something for something and something layout when we do our list comprehensions. And so we could go stem density I for I in range and obs. And so you can see as it is here, that would give us everything. And I'm going to do my trick with a backslash for a line break again since I'm running out of space. And then our good friend if to subset. So you could say if species I, and here we're testing if something is equal to, and so to do that we do two equals signs as opposed to the one equal sign when we do when we are doing an assignment. So two equal signs means you're testing equality versus assigning a value to a variable. So then we type in the value that we would want. And again, I'll make sure I'm printing out the new thing that I want to use. And we get a bunch of these 11s and then some missing data. And if I go to double check, I didn't have very many Miscanthus sinensis. So I look at all of these and sure enough they're all 11s. And then I didn't have, well I guess I have a few right here near the end. These are a bunch of missing and then one 11 and then two more at the end that were also missing. Right, so that worked out fine. All right, so those are all the little recipes and tricks that I have to show you in Python. I'm going to show you how to do all these same things in R. Some of them are a little simpler in R. And so if you're following along with the Python portion, I want you to pause right now, and I got an exercise for you. So I want you to find the first 5 stem height values that are greater than 2. And I suggest doing this in 2 steps, where you first find all of them that are greater than 2, and then you get the first 5 of those. And if that's easy and you want more, try to get the latitude and longitude just for those 5 samples. So pause for a few minutes, rewind the video if you need more help, and then try it out. Okay, welcome back. I hope you had some good luck with that exercise. Let's go over the answer to it. Okay, so as I said, the first step is you want to get the ones that are greater than 2 without worrying about how to get the first 5. So, right? Right, so we're going to do a list comprehension across stem height, kind of like we did across stem density. And so we wanted ones that were greater than 2. Right, and then I could say so again, I'm going to take a moment here to comment out my previous print command. I could put that into a variable and then do this to get the first 5, and maybe I want to print that out. Alright, and I get these 5, and I can do a quick scroll through to check that that looks right. 2.1, 2.37, 2.14, yeah, 2.56, 2.07, or 2.11, I missed one, yeah. It is right there. See, the code knows better than I do, so that's why to learn how to code. One reason. Right? I could also potentially do this all in one command. So make the list comprehension, and then this sort of stands in for the output list. And then I can subset it again with this slicing that happens afterwards. Okay, now let's do the challenge and get the latitude and longitude for those. Okay, so again, because I'm now working across multiple lists or multiple arrays, I'm going to have to do indexing again. Right, so we're going to have to do something for I in this range. So we could say latitude of I, right, because latitude is what we want to get, if stem height at I is greater than 2. And then I can also subset that to get the first 5. And I'll be bold and copy and paste it to make a longitude one before I actually test that it works. Okay, so let me see. I have my first one, which is 2.1, and then 47.19. Let's see. Right, so this is my first one, 2.1, and actually let's look at these first 3. And then I can see that those are in fact the latitude and longitude for that. Okay, and then when it finds the next one, it's at 48.5, 134.9. Right. So yeah, so that's how you do that challenge. So now let's move on to looking at R. Okay, so first off, if you hated list comprehensions from the first part of this video, good news, we won't be doing anything like that. In the second part of the video, we're going to have some simpler commands to get the same output, although there are certainly more advanced applications of list comprehensions where you do have to do something similarly complex in R, just not today. So let's again make a new script, and to follow my pattern, I'll call it indexing.r. Right, and so similarly to how I used my import command at the beginning of my Python script, I could do a source command. Right, especially this would be handy if maybe I had a complex data import that was like a dozen lines long or more. But I think I'm not going to do that because previously I imported the data set using just 2 lines of code. And copying and pasting that much code is not a big deal. It's when you get something a little bit more complicated that it's like, I don't want to copy and paste this and then have to worry about editing it over and over. And because I also cleaned up my column names a bit, I'll grab that line of code as well. So this is starting to make a case for using source, but for now I'll just keep it with my copied and pasted version. Okay, and then I'm going to click Run to run these 3 lines. You can also press Control plus Enter if you prefer. And now I can extract a vector from that data frame by column name. So if you recall, we did that with the $sign before. All right, so if you recall, that's our vector of accession names. If I want the third one, remember we're going to start indexing at number 1. And so the third, we use 1, 2, 3. 3 is the third value. So this was 1, this was 2, this is 3. And I should point out that when we get a single value in R, that still counts as a vector. It's the same type of object as this vector where we have 223 values. Versus if you're focusing on Python, you need to keep in mind that a list that you get from slicing or from a list comprehension is a different type of object from the single value that you would get by indexing like this. And in this case, using a negative index will not get us the last value. If I want the last value, I would have to do something similar to before, where I get the number of observations. So similarly to how we had the len command in Python, we have length in R. So okay, 223. You can ignore that L. The L means it's an integer. So in case that looks confusing, it would confuse me. Right, so then if I want that last value, then I have to index it like that. Or if I wanted the second to last one, I would subtract 1 from that number to go back 1. Remember, so number of observations is 223, number of observations minus 1 is 222. So we're still using directly the index. We're just getting it added in a programmatic way. Okay. And so how would I get a series of values? So we're going to do something that looks kind of like slicing, but it's not slicing. So in R, we always index a vector by another vector. So if I wanted to get the numbers 1 to 5, I can use a colon like that, and it will create this series of integers for me. All right, so this by itself is actually a vector. Versus if you tried to take if you typed in :5 in Python out of context, it would say, what is this? I don't know what to do with it. So then I can use that to get the first 5 values. And if I want them in reverse order, I just put the 5 first and then the 1 second. Right, so I could go from 5 down to 1. I could print the whole thing backwards. These are just other things I can do using that colon operator. Or if I do want to get every other one or something like that, there is a function called seek. where I actually already had the help page up, but this is how you get the help page. So I have arguments, importantly, I have from and to, and then by and length out. We usually use one of these or the other. So say I wanted to get every other sample again, I could say from 1 to n obs, and then by equals 2. And I can actually, again, run that command by itself, which I couldn't do in Python. And it's going to show me what that series of integers is. And so then I can use that for indexing. And now that is going to get me every other accession name. So as I mentioned, these things that we're using to index here are vectors. And so we can index a vector in R by any other vector. So this is how we will also get specific values if we want a set of specific values. So like before, I'll say indices I want. And here I'm using a lowercase c to construct a vector, followed by parentheses after it. And so separated by commas, I'll put in some indices that I want. And then all I have to do, my data accession, and then square brackets again. And then I put in that vector that I just made. And it will give me those indices. Now what if I want everything except for those? And I mentioned that negative indices in R don't do what they do in Python, but this is what they're for in R. So if we make the negative of a number, it will get everything except that index. Now keep in mind you won't be able to mix negative and positive because that won't make sense to R. So everything negative or everything positive. So if I put a minus sign in front of my vector that I made, it will turn everything negative. And so then if I put that minus sign here where I do the indexing, then it is going to skip that number 5, skip that number 7, and skip that number 25. Now in this case I'm indexing vectors by numbers, but they can also be indexed by true and false in R. And true-false values we also call Boolean values or logical values. And so say again I want stem diameter. Or stem density, I guess is what I was getting before, that is greater than or equal to 20. If I take this command and run it by itself, what it gets me is a bunch of trues and falses. So if I just want the stem density estimates that are greater than 20, I can index by this same true-false vector that I created. And so we only have values that are greater than 20, although you see that it did propagate the missing data. Usually we don't want that, and so a way around that is if we have missing data. If we don't have missing data, then we don't really care. But if we do this which argument, it's only going to give positions where this was true, and then that converts that back to a numeric index, which we can use for numeric indexing like we did before. So now we have stem density, but only where it's greater than 20 and non-missing. And so you'll notice that I have the stem density vector in here twice, which is At first glance it probably seems inconvenient, but it means that it's really easy to switch this out for a different vector, and then you can index one vector by another. So I can index stem density again, and let's do by species again, where we wanted it to equal Miscanthus sinensis. So again, I'm going to do 2 equals signs to test if something is equal versus 1 equals sign, which assigns a value to a variable. And then in quotes, I will put my value that I want it to equal there. And in this case, I believe there were no missing values for species. Everything was true and false. So we don't really have to use which because we don't have any missing data in there. And so if I do that, I get what I got before, where stem density was either 11 or it was missing for some values. Okay, so now I'd like you to pause the video and try the same exercise that I recommended for the Python portion. So what I want you to do is find the first 5 stem height values that are greater than 2. And if you want more of a challenge, then I want you to also get the latitude and longitude for those 5 samples. So pause for a few minutes, and then when you come back, we'll go over the answer. Okay, welcome back. So how do we get the first 5 stem heights that are greater than 2? So we're going to want to make a Boolean vector again. So is stem height greater than 2? And let's investigate that. We may have had some missing stem heights. I honestly don't remember. We did. So probably this is something we want to nest within which. And then that is going to get us the indices where stem height is greater than 2. And since this itself is a vector, we could index the first 5 right from here. So there are multiple ways that you could construct this and multiple orders you could do it in. This is just one way. Like you could have assigned this, use this to index it first and then subset it from there. But if I take this line, now I have the indices of the first 5 that are greater than 2. And because I have 3 different things I want to index with this, especially if I'm doing the challenge, then I might actually want to save the indices themselves to a variable. Rows I want, oh, let's give it a better name. Rows stem height 2. Okay, and so now you'll see over here I have this as a vector in my environment. So I could get my data stem height, right? And if I do that, then I get those 5 stem height values that were greater than 2, their first 5 anyway. And then I can take this command and just change which column I'm indexing with it. So here I can do latitude, and then here I can do longitude. Right, and so there I have the latitude and longitude for those rows as well. In the next video, I'll go into more detail about using functions. I hope to see you then.